Hey class, Mr. Rising here. Sorry I couldn't be with you today, but I did want to help you navigate the whole idea of slope and then using slope to identify parallel and perpendicular lines. The idea of the slope is the steepness of a line, right? And so as that number increases, as it goes from 1 to 2 to 3 to 4, the line gets steeper and steeper and steeper. Of course, we're reading it from left to right, and just like we read text in our language. So any 2 points on a line can be used to determine slope, but we read it from left to right. So the slope of a line going down is negative, the slope of a line going up is positive. So to find slope, you take the rise, which is the change in the y values. You divide it by the run, which is the change in the x values. And the division of those two is the slope. It is the rate of change. It's the ratio of change of rise over run. And I assume you all have been doing this for quite a while, so this is a bit of a review. Poof! Magic! Mr. Rising is now at the board. Can you hear me okay? Give me a thumbs up if you can hear me okay. All right, thanks for that thumbs up. So here it says use the slope formula to determine the slope of line JK through the points J, 3, 1, and K, 2, -1. Now, it doesn't matter which point you say is point 1 and point 2, so long as you realize that you got to keep it consistent throughout. So here's what I mean by this. Let's say that this is going to be point 1 and point 1, and then this is point 2. All right, which means this 3 is x2, and this 1 is y2, and this 2 is x1, and this is y1. And the reason we want to do that is just remember slope m equals y2 minus y1 over x2 minus x1. All right, so just based on those values, let's substitute the values in. y2 is 1 minus y1 is -1 divided by x2 is 3 and x1 is 2. So when I simplify this out, I get 1 minus a -1, or 1 plus 1, and that is 2 over 1. So my slope is actually just a simple positive 2. You could have done it the other way around. You could have said, hey, this point here, you could have said this point here was point 1 and this was point 2. You would get the same answer. You just need to be consistent throughout the problem. I realize that my voice cut off a little bit there, so I'll try to speak louder when I'm at the board. On this slide here, it talks about a summary of slope of a line. And so here it is. Positive slope goes upward from left to right. Negative slope goes downward from left to right. Zero slope would be things like y equals positive 3. So this would be y could be positive 3. Right? Now, the equation of that line. This one here, something with an undefined slope, could be as simple as x equals 2. You can see you're 2 units over, and it makes a vertical line. So the interpretation here is slope can be considered rate of change. If y represents the miles traveled and x represents time in hours, the slopes gives a rate of change in miles per hour. So let's try a little problem that has something to do with this. It says, use the graph below to estimate how far Tony will have traveled by 6:30 if his average speed stays the same. So, oh man, all right, well, wait a minute. So if he went 180 miles in 3 hours, he's traveling at a rate of 60 miles per hour. So wait, I know what his slope is. I didn't have to use the slope formula to do it. I could have. Hey, if you want me to do slope formula, okay. y2 minus y1 over x2 minus x1. And yeah, I mean, I could plug in these values. I could say, all right, 330. So we'll make this y2 and x2 and y1 and x1. I mean, I can do it this way, but I can just also recognize that I go up 60 miles for every hour I go over. And that's the whole idea of 60 up over 1, right? 60 miles per hour. But if you wanted to use the slope formula to do that, you could do it the same way. So 330 minus 180 equals, oh, that's just gorgeous math. I love it. 5.5 minus 3. So this is 1.5, and this is going to be 330 minus 180. Oh, brain. 150. Yeah. Oh, that's 2.5. I see my error. 2.5, 2.5, and that indeed is 60 miles per hour. Now, I haven't actually answered the question yet. The question states, how far Tony will have traveled by 6:30 if he continues the same speed? So wait a minute. At 5:30, he's gone 330 miles. Another hour from now, so he's going to go 330 at 5:30. Well, in an hour, it's 6:30. We need to add another 60 miles, and that's a total of 390 miles. The other way to do that is just say, hey, 6.5 times my slope of 60 miles per hour will give you 390 miles. There are a couple of theorems in section 5. One is the parallel lines theorem, and this specifically has to do with a coordinate plane. And it says, hey, in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Okay? And continuing on, any two vertical lines are parallel. Perpendicular lines theorem says, hey, in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1, which means if you say, hey, the slope of one line is 3, the slope of a line perpendicular to it is -1/3, if you multiply these together, you get a -1. And that's what they mean as a way to check. Vertical and horizontal lines are perpendicular. Well, of course they are. That makes perfect sense. So here it is. If a line has a slope of A over B, then the slope of a line perpendicular to it is -B over A. This is called an opposite reciprocal. And again, it's not true if it's a vertical and a horizontal line, because the slope of a vertical line is undefined and the slope of a horizontal line is 0. Okay, so the next thing we need to do is we need to look at given points of information to figure out if the lines are parallel, perpendicular, or neither. So 4 given points do not always determine 2 lines. You do need to make sure you graph both of the lines, that way to make sure they're not collinear. So here's the example that they give you in the book, and hopefully my drawing doesn't get in the way. It says graph each pair of lines. Use slopes to determine whether the lines are parallel, perpendicular, or neither. So step 1, graph them. W is 3, 1. 1, 2, 3, up 1. Here's W. Step 2, X is 3, -2. 1, 2, 3, -2. Oh man, wait a minute. That's a vertical line. Ah, sweet. I love vertical lines. Okay? Y is -2, 3. 1, 2, 1, 2, 3. And Z is 4, 3. So I have to go over to 4. 1, 2, 3, 4. 1, 2, 3. And I graph that one. Now at this point you're saying, wait a minute, Mr. Rising. Of course, these lines are perpendicular. I have the slope of this line, xw, the slope of this one, m is undefined. And the slope of yv, m is 0. Okay? So those according to my theorem back here, then those are definitely perpendicular lines. If you're going to do other examples of this, where you need to check to see if lines are perpendicular or parallel or whatnot, you actually need to find the slope and then evaluate if the slope is the same, or if it's opposite reciprocals, or if it is neither. And that's exactly what they want you to do in this problem here. So let me just pull up a quick piece of graph paper. Sorry to keep you waiting there. I know you guys are really just chomping at the bit to knock these problems out. All right, let's try this one here. So k is negative 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. So there's k. And then L is negative 2, negative 3. 1, 2, 1, 2, 3. All right, L. And then M is 3, 1, 2, 3, 1. And N is negative 5, negative 1. 1, 2, 3, 4, 5, negative 1 right here. All right, so here's the idea. Let me get some quick tools out. Let me do a purple line here. I'll connect these like that. Let me use a green line here. I'm going to connect those like this. Now, just eyeballing it, I know, just if I eyeball it, they're definitely not parallel. The only way I can be certain that they're perpendicular is to determine their slopes and see if they are opposite reciprocals. And that's what I'm going to do right now. All right, so let's pick a color. Let's go with yellow. So check this out. If I just turn this into a triangle real quick, you'll notice I've gone over 2. And how many have I gone down? 1, 2, 3, 4, 5, 6, 7. So the slope of this line is negative 7 over 2. That means if the slope from n to m is positive 7 over 2, then these are perpendicular. So let's try that one. I'm going to use purple to keep it, or maybe I'll use red. There we go, we'll use red here. Again, let's do the same thing here. All right, how far am I going up? I'm going up 2. How far am I going over? 1, 2, 3, 4, 5, 6, 7, 8. No. The slope of this line is 2 over 8. The slope of this one is negative 7 over 2. These are neither parallel or perpendicular. I hope that that makes sense. That's kind of an easy way to do it without doing the slope formula. Sometimes you've got points of data that are so big that you have to use the slope formula. But this is the advantage of graphing them out. I hope that helps you. I've got a few problems for you to do here. There's just 5 problems, but they will take time. So please make sure you're doing them correctly. Again, this is problems on page 186, number 12 through 24, and just do the problems, the multiples of 3. So that's 12, 15, 18, 21, and 24. Have a good one.